My name's Mike Mulia. I'm a research associate in the Ocean Energy program at the UNC Coastal Studies Institute, and I study the Gulf Stream. We're trying to understand whether the Gulf Stream is a viable source of ocean energy for the state of North Carolina. The Gulf Stream is like a giant river in the ocean. The water is really warm. It's 76, 78 degrees Fahrenheit all year round, and it transports an enormous amount of water. So the Gulf Stream has a lot to do with what the currents are doing off of North Carolina and whether water flows offshore at Cape Hatteras from the continental shelf or whether it flows offshore further to the north, and a lot of that depends on what the Gulf Stream's position is off of Cape Hatteras. And we're funded here at the Coastal Studies Institute to study the Gulf Stream because it may be the only viable source of ocean energy for the state of North Carolina that could actually power homes for the entire state. The amount of water that flows off of Cape Hatteras in the Gulf Stream is immense. So there are different estimates from 60 to 90 sphere drips, which is a unit that we use in oceanography, and a sphere drip is 1 million cubic meters of water per second. Relatively speaking, it's between 35 and 45 times the amount of all the river flow in the entire world off of Cape Hatteras is what the amount of water that the Gulf Stream is moving. At this point, there is no turbine, large-scale turbine that's been designed and tested that could harness flow from the Gulf Stream as we envision it. So we envision something on the order of like a wind turbine, something that's 30 to maybe 100 meters in diameter, something almost the size of a football field rotating underwater. Those are the ideas that have been put forward, but again, it's very new. So it's a new technology. It's something that we're exploring now, trying to understand what the implications are and what kind of size you could put underneath the water. So if you imagine that you have a giant turbine underwater and you want to tie it with an anchor line or a mooring to the bottom, you have to understand what the current dynamics are, not just at the turbine, but along the mooring line or the different forces that the turbine might experience on either end of the propeller, because there are other flows of water other than the Gulf Stream where we're looking that flow beneath the Gulf Stream. And so we measure those flows, and we can inform the engineering community about what types of flows, what speeds, and what the velocity shears like this would be in the water column when they're designing something to take advantage of that energy. We deploy an acoustic Doppler current profiler in a pod that actually goes on the bottom, and it sits on the bottom and it measures what the currents are doing above it over nearly the entire water column every 10 minutes. There it goes.
Woo! It looks good!
Woo! That was awesome! You can see it go down. So every 10 minutes I'm taking a snapshot of what the current's doing above that instrument, and we have nearly 3 years of measurements at what we consider to be the optimal location for getting Gulf Stream power, and we're really starting to understand how that power density from the stream varies at the location that we've chosen. As the crow flies, it's almost straight east or straight offshore of Cape Hatteras, right where the land point is located. The reason that we've chosen that location is the shelf slope is extremely steep there, and what that does is constrain the variability and position of the Gulf Stream. And so the variability and position is least off of Cape Hatteras at the location that we've chosen after the Gulf Stream leaves the Florida Straits. So we've really focused on that. We've also focused on water depths that are probably going to be less than 400 meters at this point, just to keep the expense of getting that energy down. I think when we talk about the Coastal Studies Institute's Ocean Energy Program, it's essential to mention all the partners that have made grand contributions to what we do. UNC Chapel Hill, NC State University, UNC Charlotte, all of these folks, all of these researchers play an essential role in our understanding of ocean energy here in North Carolina, and they've contributed countless hours to doing so. I think it's important because we need to diversify our sources of energy, right? We consume a lot of energy, and we don't know how long energy from non-renewable sources will be available from oil and coal. So it might be in our best interest to look at other sources of energy that don't do as much damage to the environment.